I'm happy to speak about my joint work with Erik Hurst and Dan Black about the college gender wage gap and human capital specialization. In broad strokes, what we do in this project is link and expand on two classic literatures when it comes to human capital specialization and gender. The first literature is looking within some specific institutions and cohorts and also in older survey data at patterns in sorting by gender when it comes to undergraduate field of study, and shows evidence that men and women sort differentially when it comes to undergraduate field of study. And this is consistent with what we see in the occupational sorting literature. The second literature takes this fact that men and women sort differentially when it comes to undergraduate field of study and connects it to labor market outcomes such as employment and earnings. So again, in this project, we're going to link and expand on these two literatures in a modern data set, specifically the American Community Survey, which starting in 2009 began asking questions of people with at least bachelor's attainment about their undergraduate field of study. We're going to focus on the post-recession years from 2014 to 2017 in this data to collect information about the 1950 through the 1990 birth cohorts when it comes to undergraduate field of study, occupation, employment, and importantly, earnings. The innovation in this paper comes in two buckets. So the first is in how we describe sorting. So we're going to introduce some new indices to just basically give us a larger toolkit in how we describe sorting, and specifically we're going to place sorting into a price space. Secondly, we're going to show some evidence about the linkages between college major and occupation by gender and show evidence of differential sorting by gender when it comes to that mapping. So really what we're trying to do when it comes to the mapping part of the paper is reduce the dimensionality of a high dimension problem, which is moving from 136 detailed majors to 251 occupations. With that said, I'll get started on the details of the paper. I do have a disclosure to make. It's not about the data. We use public data, but it's a 2020 disclosure, which is to say that this talk is pre-recorded. So if something should happen between now and July 25th and there's no longer college, maybe we could just use this evidence to better understand human capital sorting by gender in whatever way that manifests itself in the future. This project tries to gain greater insight into human capital sorting that happens pre-market and connect that to sorting that happens in the market, and then use that to explain gender differences in employment and wages. Specifically, first we document cross-cohort patterns in gender sorting by both undergraduate major and occupation. Secondly, we introduce new indices that measure specialization. Third, we're going to examine gender differences in the mapping between undergraduate major and occupation. And then fourth, we're going to assess the contributions of major and occupation to college gender gaps in employment, hours worked, and wages. So what we find is that first, across all birth cohorts, women are sorted into majors with lower potential earnings. That is to say that even if women were rewarded the same way that men are rewarded who have the same major, they've sorted into majors with lower potential earnings. Secondly, we find that conditional on major, women subsequently sort into occupations with lower potential earnings. So that's our mapping result. Third, we find that gender differences in major explain a substantial portion of the college gender gap in wages, and that's above and beyond what's explained by the occupational sorting literature. So this result connects to evidence on occupational sorting and wages, so work that's done by Blau and Kahn and Cortez and Pan, to name a few. And lastly, we find that some of the gender differences in occupational sorting conditional on college major can be partially explained by women sorting into occupation with lower potential hours worked. So that really speaks to the literature on the search for flexibility and gender. We're going to motivate the project by looking at gender sorting within broad major categories in a set of male-dominated majors, that's the figure on the left, and in a set of female-dominated majors, that's the figure on the right. The y-axis of both figures is going to be the number of women to the number of men in the major, and the x-axis is the 5-year birth cohort. So two big takeaways in these figures. So men and women do sort differentially when it comes to undergraduate major choice. They're not exactly in the same majors. And then also there's a takeaway when it comes to kind of cross-cohort patterns, and that is that some majors we see convergence over time. So we see men and women moving closer to parity in the major. So things like biology or engineering and male-dominated majors, and things like nursing and pharmacy and female-dominated majors. Other majors have become increasingly male or increasingly female over time, and then we see some majors that have remained static over time. So different patterns when it comes within major to convergence over time. So the previous slide I showed you some sorting patterns when it comes to a select set of broad major categories. We would like to get an idea of overall sorting patterns by gender across cohorts. And so the first pass that we're going to take at this is using a measure that is going to be pretty familiar to most of the people in this virtual room, and that's a Duncan index. We're just going to renormalize it and call it an inverse Duncan index. So it's going to be 1 minus the traditional Duncan index. So kind of a classic construction, it's just going to be 1/2 of the summation of the male shares within a major minus the female shares within a major. And so this number, as it tends towards 1, we're going to approach gender parity in sorting again, because this is an inverse Duncan, and a classic Duncan. As you approach 0, you're going to approach parity in sorting. So Duncan indices are kind of the main summary statistic that those of us who are interested in sorting by race or gender have to describe sorting patterns. And it's limited because it doesn't take rank into account. And so what that means kind of in an occupational context is that if all men were lawyers and all women were doctors, the Duncan index is going to yield the same number as if all men were lawyers and all women are garbage collectors. And we know that these are very different scenarios when it comes to earnings implications. So we wanted to take a similarity index and set it in a price space so that it would have an economic interpretation. And so what we're going to do is develop a potential wage index, which is going to be really similar to what Marianne Bertrand does in her 2018 paper. And so we start by developing a potential wage within a major, and so that's just going to be the wage of white native men in their peak earning years within a major. So the median wage of that group of men, so that's this Y bar superscript M subscript male. That's the potential wage, and then we're going to weight the potential wage by the distribution of men and women within that major category. And so this index is going to be equal to 0 if major choices of women yield the same potential wage as their male counterparts. So this graph shows the potential wage index in majors, that's the black solid line, and in occupations, that's the blue dashed line, for the birth cohorts from 1950 to 1990. And so if we start with looking at occupations, we can see that in price space, we also kind of see this movement towards parity from the 1950 birth cohorts to the 1990 birth cohorts. So kind of this slow movement towards parity in the potential wage space when it comes to occupation and gender. In the major space, what we see is that in the 1950 birth cohort, women sorted into majors that reduced their potential wages by 12.5% relative to their male cohorts. By the 1990 birth cohort, that's going to be a 9.5% difference between women and men when it comes to potential wages as determined by major. And so we can also see the shape of this graph for major looks quite different than what's going on with occupation. So here we kind of see this movement towards parity from the 1950 birth cohorts to the 1975 birth cohort, and then we kind of see this leveling off and reduction that happens from the 1975 birth cohort to the 1990 birth cohort. So an interesting fact from the previous slide is that there's a wedge between the potential wage index for major and the potential wage index for occupation, such that the potential wage index for occupation is lower than the potential wage index for major. So this implies that conditional on major, women must be sorting into occupations with lower potential wages compared to their male counterparts with the same majors. So we wanted to think about summary statistics that would help us summarize these mapping patterns between major and occupation and be able to describe these mapping patterns across cohorts. So we start with a measure that's going to tell us about the concentration of occupational choices conditional on major. So what we're trying to get at here is thinking about, conditional on having been an engineering major, are women sorting into a broader set of occupations than men who are maybe more narrowly sorting into engineering occupations. And so in order to describe the concentration of sorting into major conditional or sorting into occupational conditional on major, we're going to use Herfindahl-Hirschman index. And so specifically we create a cross-occupation Herfindahl-Hirschman index for each gender, cohort, and major. And so this index is going to range between 0 and 1, and as it approaches 1, that's going to tell us that occupational sorting is more concentrated, and as it tends towards 0, that's going to tell us that occupational sorting is less concentrated or more dispersed. So these figures are going to describe some patterns with respect to the Herfindahl-Hirschman indexes. So again, trying to describe the amount of dispersion there is in occupational choice conditional on major. So if we look at panel A, the x-axis is going to be the female minus the male Herfindahl-Hirschman index in occupations, and the x-axis is going to be the female minus male share in the major. So we can see here that there's some symmetry in that the female-dominated majors see a more concentrated occupational sorting by women in the major, and that for male-dominated majors, they're going to see more concentrated occupational sorting for men in that major. And so panel B is going to show us a dimension in which this kind of sorting is not created equal when it comes to the concentration of occupational sorting conditional on major. And so it's going to take that same y-axis from panel A, so that's the female minus male Herfindahl-Hirschman index, and then the x-axis is going to be the potential wage based on the major. And so what we can see is that in the lowest potential wage majors, women are going to have more concentrated occupational choices, and that in the highest potential wage majors, women are going to have more dispersed occupational choices than men. And so this kind of suggests that for low potential wage majors, that men are trying to escape maybe low potential wages, and they're kind of scattering towards a broader set of occupations. So this table is going to show evidence of differential mapping between undergraduate major and occupation for men and women within a set of broad major categories. And the last column of this table is going to give us the Herfindahl-Hirschman index of occupational choice within each broad major category. So recall that as this index tends towards 1, that's going to represent a tighter concentration of occupational choices conditional on major. So within the education majors, we can see that women who are education majors are going to be sorted into a more concentrated set of occupations than men who are education majors. And if we look down to engineering majors, we can see that overall, engineers are sorted into a broader set of occupations than education majors, and that male engineering majors are slightly more likely to sort into a more concentrated set of occupations than women who are engineering majors. The other big takeaway from this table is that there are significant rank effects when it comes to this mapping between undergraduate major and occupation. And so we can see within education majors that women who are education majors are twice as likely as men who are education majors to end up in administrative support roles, and men who are education majors are twice as likely as women who are education majors to end up in executive manager roles. And so for all of the set of broad majors in this table, it's true that men are more likely to become executives or managers conditional on having the same made the same major choice as their female counterparts. And this is actually true for the full set of majors, so we're just showing you a select set here. And so this is important because our Herfindahl-Hirschman index is not going to take rank into account. It's just going to describe the concentration of sorting. And so we would like to have an additional measure that's going to describe these mapping patterns between major and occupation that's going to take rank into effect. So much like we did earlier, we want to set this index into a price space. And so we're going to introduce an index that's going to think about mapping between major and occupation, taking potential wages into account. So the last index that we introduced in the paper, again, is trying to provide a summary statistic to describe differential mappings between major and occupation for each gender and cohort. And so what we do is very similar to what we do in the construction of our first potential wage index, is that we're going to weight the potential wage based on occupation by the distribution of women in that occupation conditional on making major selection M compared to the distribution of men in those occupations conditional on having majored in major M as well. So when this index equals 0, that means that the occupations of women yield the same potential wage as their male counterparts who majored in the same subject. So in this graph, we wanted to be able to summarize the rank effects of differential mapping between major and occupation for men and women over the full set of majors. So what we've done on the x-axis is we've binned majors based on the potential log wage of the major into deciles, and then on the y-axis we're computing the within bin mean potential log wage based on the occupation. And so the dashed lines here are going to be this measure for the male series, and the solid lines are going to be this measure for the female series. The color variations are cohorts. So the black lines are the 1955 cohorts, the red line's the 1965 cohort, and then the blue line's the youngest cohort here, that's the 1975 cohort. So we can think of all these cohorts as kind of set in their occupations, potentially, and also we would think of undergraduate major as being very sticky. And so what we can see here is that the male series are above the female series at every bin for all of the cohorts. And so what this means is that conditional on majoring in the same subject matter, men are sorted into a higher set of potential wage occupations. And so they're set into a more remunerative set of occupations, and women having made the same undergraduate major choice. We don't see much convergence over time across the cohorts when it comes to the lower bins here for majors, and where we see the convergence happening across cohort is actually in the highest potential major bins. And so things like STEM are kind of leading the charge for the convergence over time in terms of mapping. So there's much more in this paper, but I'm going to leave you with some evidence on the big question that we have for this research agenda, which is how much does major matter? So how much does pre-market sorting matter with respect to the college gender wage gap above and beyond market sorting? So Brown and Corcoran 1997 shows the first evidence on this, which in the SIP and in the NLS 72 for cohorts kind of predating the overtaking in terms of college completion by women, that controlling for just 20 broad major categories improves explanatory power with respect to the college gender wage gap. And so here we can see that moving from our raw college gender wage gap, that's column 1, only controlling for some demographics, to our fully controlled model with both major and occupation, we're cutting the gender wage gap in half by controlling for both pre-market sorting and market sorting. And we can see that major has independent explanatory power. We do a bounding exercise, which is saying, if the overtaking had never happened, what would these coefficients look like? And so our college gender wage gap would have been bound between 0.21 and 0.27, and our fully specified gender wage gap would have been bound between 0.11 and 0.12. And then lastly, we're going to look across cohorts, and we can see that major has always been important over time for explaining the college gender wage gap, whereas occupation is becoming less important over time in terms of explaining the college gender wage gap. So with that, I'll close, very close to 20 minutes, and I thank you for your attention, and I hope you'll check out our paper.